Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from October-November 2022, Paper 1, Variant 1. And in today's class, we will start from question number 11. We have already discussed from question number 1 to question number 10 in part 1. So for those questions, you can search for October-November 2022, Paper 1, Variant 1, Part 01. And you can find a detailed solution about question 1 to question 10 in my previous video. The video we uploaded yesterday. And in today's lesson, we will start from question number 11 and we will try to discuss from question number 11 to question number 20. Means next 10 questions in this session we will discuss. And as always, we will discuss these questions in detail so you can improve your conceptual understanding and you can have better understanding about these questions. The main goal of these videos is to help you to improve your conceptual understanding so you can have better understanding of physics and next time you can handle questions with confidence. Let's study together. Let's improve together. For question number 11, it is given to us a square board of side length X hangs freely from a nail P as shown in the figure. The board has uniform thickness and is made from material of uniform density. A second square board of side length 2x is made of same material and has the same thickness as the original board. The second board is then hung from a nail Q. Nails P and Q are at the same height. We need to find out what is the vertical distance between the positions of the centers of gravity of two boards. So first thing in this case we need to understand is that when you hang any board freely, the center of mass always lies below point of suspension. You can simply understand from here. Let's say this is the marker. If I let it go, means this is hanging freely. When it will stop, its center of mass will be right below the point of suspension, means the point where I am holding this marker. So it will lies right below point of suspension, means when its moment is 0. So this is pivot point and center of mass has to be right below this one. So the line of action of the force will pass through the pivot, so there will be no moment. So point of suspension always above center of mass, or simply you can say center of mass always lie below point of suspension. So this is first point you need to understand. If you have understanding of this one, now simply we can draw the line. We can draw the line from point of suspension to other end. So it means center of mass is on this line. And same we can repeat for this second board. And in this case you can see the center of mass will lie on this line. Now we need to find out the location of center of mass. And let's say the length of this line, red line, let's say this one is equal to small l. We can take this is small l. Now, and for this one we can say this is capital L. And center of mass will be halfway. So we need to find out first of all what is value of L. So if you look at this side, these two sides, you can see this angle between these two sides, angle is 90 degrees. And if you look at these two sides, you can also see this angle is 90 degrees. It simply means that this is a right angle triangle. So as this is a right angle triangle, so simply we can say in this case L square will be equal to x square plus x square, and L in this case means L square, this will be equal to 2 times x square. So from here we can find out value of L. L will be equal to root of 2 times x. So this is value of L. So simply we can say this is equal to root of 2 times x. And now we try to find value of capital L. So capital L you can also do in the same way. This one will be equal to L square. L square will be equal to 2x square plus 2x square. And from here we can write down this will be equal to 4x square plus 4x square. If we add these two together, we will get this is 8x square. And here we have L square. We need L, so we have to take square root on both sides. So this will be 2 root of 2 times x. So we have value of small l and also we have value of capital L. Now we need to find out the value of center of mass. I mean the distance from here to here. This distance we need to find out. And that distance will be L by 2. So in this case, we can say LCM. LCM. So means we are saying this part. LCM. And LCM will be equal to L by 2. So in this case, this is equal to root of 2 times x. And here also we can say LCM small up to the center of mass. So we can say this is small LCM. And this will be equal to root of 2 times x divided by 2. And this one we can write down. This will be equal to x over root of 2. Root of 2. Now we need to find the difference between these two. Means we need to find out LCM minus small LCM. Difference between these two. So we have LCM, that is root of 2 times x, minus we have x divided by root of 2. Now from here, how we can write down, this will be root of 2 and root 2 multiplied with root 2, we will get this will be 2x, and here we will get x. And finally, this one will be equal to x divided by root of 2. And this is our final answer. So this is how you can approach this problem. And this is a beautiful way to answer this kind of problem. For question number 12, it is given to us forces are applied to a rigid object. The forces all act in the same plane. In which diagram is the object in equilibrium? So first of all, let's try to understand what is meaning of equilibrium. When we say object is in static equilibrium, it simply means that resultant force in any direction. We can simply say net force in any direction is equal to 0, and also the net moment about any point is equal to 0. It means the clockwise moment about any point has to be equal to counterclockwise moment. Now simply we can say net moment is equal to 0. Net moment is equal to 0. So simply we can say net moment about any point has to be equal to 0. Now this is what we need to figure out. But before we answer this question, let me tell you this question is from May-June 2016 paper 1-1, means paper 1 variant 1. So this is a repeated question, the same question, 100% same question you will see in 2016 paper 1 variant 1, same question. Now let's try to answer this question. In order to answer this question, if you look at option A, in this case we will write down first of all F net. Is F net is equal to 0 or not? In this case F net is equal to 0 because the downward force is F and upward force is also F, so it means F net is equal to 0. Now we need to find out, is the net moment in this case, is it equal to 0 or not? Net moment. So if you look at this point, let's say we take moment about this point. If we take moment about this point, in this case you will see net moment due to this one will be 0. Moment due to this one, this will be clockwise. So this moment will be clockwise, and moment due to this one, this will be anti-clockwise, and they are the same because force is the same and distance of the force from the pivot also is the same. So it means clockwise moment in this case is equal to anti-clockwise moment. So simply we can say net moment is equal to 0. So the answer for this question is A. So this is in static equilibrium. Now let's try to check option B, why B is not answered. So first thing we will look at net force in this case. So we have 2F acting down, 2F is acting vertically up, and there is no force along horizontal. So the net force in any direction in this case is equal to 0. But if you look at net moment now, let's say we take our pivot point here. So this is our pivot point. So we can take pivot here. So moment due to these forces will be 0, and moment due to this one, moment due to this one will be anti-clockwise, and moment due to this one also will be anti-clockwise. So the net moment will not be equal to 0. So in this case, net moment will not be equal to 0. So it means this is not in static equilibrium. We can go to next now, and also we can take our pivot in this case at this point. F net in this case is not equal to 0 because 2F is acting up, 1F is down, so F net is not equal to 0. So we can say F net is not equal to 0. But moment, net moment is 0 because due to this one, this moment will be clockwise, and moment due to this one, it will be anti-clockwise. So the net moment is 0. So we can say net moment in this case is equal to 0 because forces have the same magnitude and the distance, perpendicular distance from the pivot is also the same. So the net moment is equal to 0. Now if you look at this option, in this case we can also take over moment about this point. So you can see net force is 0 in this case because 1F is acting vertically down and 1F is acting vertically up. So the net force is equal to 0. But net moment is not equal to 0 because moment due to this one, this is anti-clockwise, and moment due to this one, this is clockwise. These two moments, they will cancel each other, but there is still net moment due to this force, and this one will be counterclockwise. So this will be anti-clockwise. So in this case, net moment is not equal to 0. Net moment is not equal to 0. So this is not equal to 0. So that's the reason B, C, and D, they are not possible answers. So the answer for this question is A. And this is a typical type of question. You need to understand how to handle this type of problems. For question number 13, it is given to us a rod XY has negligible mass and the length of the rod is 75 centimeters, as you can see here. The rod is suspended from a fixed point P by a string attached to end X. So as you can see here, this is end X and it is suspended from this point P, and this is string, and string is also massless. So string is massless. It is also given to us an object of mass 11 kg is suspended by a string. So this is also a string, is attached to the rod at a distance of 25 centimeters from end X. So the object is attached here with this rod. We need to find out which vertically upward force acting on end Y, means on this end vertically upward, so mean this force has to be vertically acting upward, so we can say this force is F. On end Y of the rod would hold the rod horizontally in equilibrium. So this rod has to be in equilibrium. As it is given to you, the rod is in equilibrium. It simply means that you need to use conditions for equilibrium to find the answer. So we have two conditions. First condition, net force in any direction has to be 0. The second condition, moment about any point has to be equal to 0. Means the net moment about any point has to be equal to 0. So we can use net force concept or we can use net moment concept and we can answer this problem. So we need to use a smart way to answer this problem. The smart way is we can take moment about end X, means we can place our pivot here. So if we take moment about this end, net moment has to be equal to 0. So moment due to this one, this moment will be clockwise, and moment due to this one, this will be anti-clockwise. So this will be clockwise and this moment will be counterclockwise, and these two moments has to be equal to 0. So in this case, simply we can say moment due to this one, we have mass that is 11 kgs and we need to multiply with 9.81, and distance in this case is given to you, this is 25 centimeters. You don't need to convert this one into meters. You can solve without that because centimeter on both sides will be cancelled. If you are not very clear, you can multiply this one with 10 to minus 2, but it doesn't matter. And on other end, we have force F and perpendicular distance that is 75 centimeters. So this is 10 to negative 2. Now simply you can solve for F. If we solve this one for F, our answer will be about 36 newtons. So the answer for this question is C. So this is how you can approach a very straightforward question if your concept about equilibrium is clear. A lot of static equilibrium questions can be answered based on this concept. Means two conditions you have to use. Net moment about any point has to be 0. And net force in any direction has to be equal to 0. Sometimes we can use only one condition, we can answer problem. Sometimes we have to use both of them to find the solution. So this is the only way to answer this type of problems. For question number 14, it is given to us the density of water is 1.0 grams per cubic centimeter and density of glycerine is 1.3 grams per cubic centimeter. Water is added to a measuring cylinder containing 40 cubic centimeters of glycerine so that the density of mixture is 1.1 grams per cubic centimeter. Assume that the mixing process does not change the total volume of the liquid, and we need to find out what is volume of water added. Before we answer this question, let me tell you this question is from May-June 2018, paper 1, variant 2, question number 10. You will see the same question in May-June 2018, 100% same. So it's very important that you go through past papers before your final exam. So maybe some of the questions will be repeated and you will be more confident to answer those questions. So it's very good practice to do past papers before your final exam. So let's try to answer this question now. For this question, it is given to you, density of of the mixture is this one. So we can start with the best way to answer this type of problems is, first thing, you can write down mass of the mixture. So in this case, I will be using capital M for mass of the mixture. And mass of the mixture, this one has to be equal to mass of the water plus mass of glycerine. So beautiful way to answer this type of problem. Always start with mass of the mixture, and that one has to be equal to mass of water and mass of glycerine in this case. So what is mass of mixture? Mass of mixture will be equal to density of the mixture plus volume of the mixture, and volume of the mixture will be equal to volume of water plus volume of glycerine. So we can simply write down in this form. And mass of water will be equal to density of water times the volume of water plus density of glycerine times volume of glycerine. Now simply you need to plug in values. That's all. This is the main idea. Rest is just you need to simplify calculation. That's all. Now in this case, density of mixture is given. We can write in simply this is 1.1, and we have volume of water. This is what we need to find out. But the volume of glycerine is given, that is 40. So you can write down this is 40 plus density of water is given, that is 1, and volume of water you need to find out. So this is VW. Density of glycerine is given, that is 1.3, and volume of glycerine is given, that is 40. Now we can simplify. So here you will get this is 1.1 volume of water plus you have 1.1 times 40. So we can draw these brackets, and here we have volume of water, and here you have 1.3 times 40. We need to find out in this case volume of water, so we can rearrange for volume of water. So for volume of water, we can write on here this is 1.1 VW, and here you have VW means you can take this one on left side and this one we can take on right side. So here it will be 1.3 times 40 minus you have 1.1 times 40. From here we can take VW common. So you will VW, if you take common from here, you will get this is 1.1 minus 1, and here you can take 40 common, so you will get 1.3 minus 1.1. Now we can further simplify and we can find out value of volume of water. So from left side we can say VW, this is 0.1, and from right side we have 40, this is multiplied by 0.2. So VW in this case simply is 40 times 0.2 divided by 0.1. So if we cancel here, we can say this is 2. So the 40 times 2, this is simply equal to 80. So our answer for this question is D. So this is 80. And we are using cubic centimeters. So volume is 80 cubic centimeters. So this is our final answer. So this is how you can approach any question, mean the same type of question about mixture. You can use this technique, and the best way is to start it with mass, and then you can go to the second step and you will be able to find the answer. I hope this question is clear to you. Let's move on to next one. For question number 15, it is given to us a box in the shape of a cube falls from a ship into the sea. The box lands with its lower face level with the surface of the sea. The box begins to sink, becomes totally submerged, and then sinks deeper into the sea. As the box sinks, the lower face is always parallel to the surface of the sea, which graph best represent the variation of the upthrust acting on the box with depth of its lower face below the surface of the sea. So beautiful question on upthrust. So first of all, let's try to understand when it is just at the surface, just at the surface. So in this case, it is not inside the water. So it is just at the surface. So we can simply say box on the surface of the sea. So this is given to you. Box is at the surface of the sea. So we can draw this one here. You can see this one in a very clear way. So just at the surface. So you can see it is just at the surface. So this is not inside. So this is not inside water. As it is not inside water, it means there will be no upthrust. So no upthrust. What is upthrust? Upthrust actually, this is upward force and this is equal to weight of fluid displaced. So this is equal to weight of fluid displaced. So we can write down weight of fluid displaced. So this is the main concept you need to understand. Weight of fluid displaced. So very important to understand what is upthrust. And upthrust, let's say this is U, and upthrust will be equal to the density of the fluid times G times volume of fluid displaced. So this is volume of fluid displaced. So volume of fluid displaced. Now let's try to understand. When it is at the surface, there is no volume of fluid displaced. I will say volume FD, volume of fluid displaced. As this one is equal to 0, so the upthrust is equal to 0. Now we need to understand how upthrust is depending on depth. So we can little bit write down in a better way so we can understand how upthrust is linked with that. So we can say rho Ft and the volume of fluid displaced. So we can write down this one in form of volume of the cube. Volume of cube inside water. So we can say that will be area, cross-sectional area means the cross-sectional area, this cross-sectional area times H. H is the depth inside water. So from here you can say U is directly proportional to H, means is directly proportional to depth. So it is directly proportional to depth because density of the fluid is constant, G is constant, and cross-sectional area of cube is also constant. So it's directly proportional to H. And upthrust will go on increasing until this box, I will simply draw here one small box, until box is fully submerged, means it is inside the water. Upthrust will increase, means upthrust will increase when depth is equal to 0 to depth is equal to H. Depth is equal to 0 to depth is equal to small h. Is equal to small h. In this case, we are saying is small h, the height of the box. After that, upthrust will be constant because after that, you can see the volume of fluid displaced. This will stay constant, G constant, density of fluid constant, so upthrust will stay constant. So anywhere inside this water, upthrust on this cube will be same. So after h, upthrust has to be same. So now simply you can find out the answer. I hope you will simply say, in this case it is telling you upthrust go on increasing. That is not possible. Upthrust always stay constant. That is also wrong. Upthrust increase up to depth is equal to h. After that this is constant. This one is right. So this is the point when it is fully submerged. We can also say when fully submerged, when it is fully submerged. So this is the point when it is fully submerged. After that, upthrust will remain constant because volume of fluid displaced, this will be same. G is a constant, density of fluid is constant, so upthrust will stay constant. So this is the answer, but this is not possible. This one is not possible because these two quantities are directly proportional. So this one is not possible. So the answer for this question is C. Very nice question. For question number 16, it is given to us a spring is compressed by a mass as shown in the figure. Which statement describes the changes to the energy of the spring when it is compressed by the mass? Now, first thing we need to understand, in this case, when this spring is compressed, its gravitational potential energy will decrease because its center of mass will go down. So we can take a reference point. So we can take this reference line. Here we can take h is equal to 0. The height is equal to 0. So the GPE at this point is equal to 0. So when spring is compressed, its height of center of mass will decrease. As height of center of mass will decrease, so we will say GPE in this case will decrease because height of center of mass of the spring, that will go down. As this will go down, GPE will go down. Now the next thing we need to understand, how about elastic potential energy? When spring is compressed, elastic potential energy, we need to understand EPE. This is equal to 1/2 kx squared. So when the spring is compressed, x will increase, mean the compression will increase. So as compression will increase, its EPE will increase. So it will store more and more elastic potential energy. Here elastic potential energy is equal to 0 because x is equal to 0. So we can say in this case EPE is equal to 0. So we can say EPE is equal to 0. Why EPE equal to 0? Because compression in the spring spring is equal to 0. So simply you need to understand for this question, GPE will decrease because center of mass of the spring will decrease, and EPE will increase because compression in the spring will increase. So we can use this understanding and we can find the answer. For option A, it is given to us spring gains gravitational potential energy. This one is wrong. It lose actually gravitational potential energy. So A is not the answer. Spring gains gravitational potential energy. This is also wrong. It lose. This is wrong. The spring loses gravitational potential energy and also loses EPE. This one is wrong. It gains EPE. So C is also wrong. If you look at option D, spring loses GPE and gains EPE. So this is the right answer. So this is simply you can answer pretty straightforward question if you have some understanding about GPE and EPE, elastic potential energy. For question number 17, it is given to us a man of mass 75 kgs runs up a staircase consisting of 30 steps. Each step is 20 centimeters high. The man takes a time of 7.0 seconds to run from the bottom of the staircase to the top. What is the average rate of increase of gravitational potential energy of the man? So very straightforward question. Simply this is asking you to calculate rate of increase of gravitational potential energy. So first of all, we can calculate in this case gravitational potential energy. The change in gravitational energy means delta GPE, the change in gravitational potential energy. That one will be equal to mass of the person times the change in height. And we need to calculate rate of increase. So we can divide this one by time. So we can say delta GPE means the total change in gravitational potential energy. If we divide this one by total time taken, we can calculate rate of increase of GPE, means the average rate of increase of GPE. Now in this case, simply we need to plug in values. So this is the rate of increase of GPE. In this case, mass of the person is given, that is equal to 75 kgs, and G is constant, that is 9.81. Height we need to find out. One step is 20 centimeters high and there are 30 steps. So 30 times 20 centimeters mean 0.20 meters. Just divide by 100 and divided by time taken. Time taken is 7.0 seconds. Now if we solve this one, our answer will be 634 because this is rate of increase of joules per second. So this is our final answer. So the answer for this question is 6. For question number 18, it is given to us an alpha particle has 2.2 times 10 to negative 13 joules of kinetic energy, and we need to find out the speed of alpha particle. Very straightforward question, just based on kinetic energy concept. So simply we can write down in this case kinetic energy will be equal to 1/2 mv square, and we need to find out speed in this case. So speed will be equal to 2 times of kinetic energy divided by, so let me write down this kinetic energy in a proper way so it will look a little bit nicer. So we have 2 times Ke, and this will be divided by m, and if you take root of this one, we can calculate value of speed of alpha particle. So in this case, we have kinetic energy of alpha particle, that is 2.2 times 10 to minus 13 and divided by mass of alpha particle. And mass of alpha particle, we need to understand alpha particle consists of 2 protons and 2 neutrons. So the mass of alpha particle is equal to 4u, and 1u is equal to 1.66 times 10 to minus 27 kgs, and you can find the value of atomic mass unit in data. So it simply means that the mass of alpha particle is equal to 4 times 1.66 times 10 to minus 27 kgs, and we need to replace m with this. So this is mass of alpha particle. So simply if we write on here 1.66 times 10 to negative 27 and we take root of this one, we can calculate speed of alpha particle, and speed of alpha particle in this case will be equal to 8.1 up to 2 SF times 10 to 6 meters per second. So this is value of speed. So the answer for this question is C. Very straightforward question. For question number 19, it is given to us identical springs are joined in 4 arrangements. Which arrangement has the same spring constant as a single spring? So first of all, we can imagine a single spring. So imagine that we have a single spring. So this one is a single spring. So this is single spring. And let's say we apply force on this single spring and it is extended by certain amount. So we can say it is extended by this amount. Extension in this one, let's say, is equal to X after applying force F. So we can say when we apply force F on this one, it is extended by this amount. And let's say spring constant of this one is K. Now we need to look at given options. If you look at given option, in first case, let's say the force here is F. When the force here is F, force acting on this spring also will be F. Force acting on this spring also will be F. So the extension in spring 1 will be X. Extension in this spring also will be X. So it means in this case, K will be equal to F divided by total extension, that is 2X. Means K nu in this case, we can say this is K nu. So this will be K divided by 2 because K here is equal to F by X. So this is half. The value of this K will be half, means this spring will be more flexible. Now if you look at this arrangement, in this case again we apply the same force F. So the force on this spring will be F by 2 and spring on this force also will be F by 2. Means force will be divided into 2 parts. As force on this one is half and force on this one is half, so extension also will be half. So the extension we will say in this case this will be K X by 2 and here extension will be also X by 2. So now we can find out the value of spring constant. So we can find out K nu. So K nu in this case, we have the force and extension in this case is total force and total extension. So this is X by 2. So in this case, we have K nu, that one will be equal to 2F by X. So we will get this is 2 times of K, means spring in this case is more stiff because it has higher value of spring constant. And now we can go to the next one. So in this case, again, we apply force F. So in this case, the force on this one will be F by 2 and force on this spring also will be F by 2. Force on this spring acting will be F by 2. These springs are massless. So force on this spring also will be F by 2. Now, if you look at extension of this spring, extension of this one will be X by 2. Extension of this one will be X by 2. And extension of this one also will be X by 2. Extension of this one will be X by 2. So what is the total extension? Total extension will be X by 2 plus X by 2 means X. So we can find out K nu in this case. K nu will be equal to total force divided by total extension. Total extension in this case we have X. So it simply means that K nu, this is equal to K. So this one is right answer for this question. So this one is the answer. So it means C is the right answer. So let's try to understand this part D as well. If you look at D, for this one we have force F that is acting here. So we can write on force F. So force on this spring will be acting, force on this spring will be F, and force acting on this spring will be F by 2. Force acting on this spring also will be F by 2. So the extension in this spring, will be X by 2. Extension in this spring also will be X by 2. Extension in this spring will be X. So we can find out value of K nu. K nu will be equal to the total force divided by total extension. So in this case, total extension we have X plus X by 2. So it means this is 3X by 2. Or simply we can say this one will be equal to 2F divided by 3X. 2F divided by 3. So this one is minus k mu. Or simply we can say this one will be equal to 2 by 3k. So this is how we can find value of k for this arrangement as well. So this is how you can approach this problem. I hope this one is clear, and answer for this question is C. You can also understand when the springs are connected in parallel. So this is another way to answer this problem. You can simply use formula if you're not clear with concept. When springs are connected in parallel, they are like resistors connected in series. Means the K effective in this case will be equal to K1 plus K2. And when springs are connected in series means like this. They are connected in series. K effective is like resistors connected in parallel. This one will be equal to 1 over, so this will be equal to 1 over K effective equal to 1 over K1 plus 1 over K2 and so on. So these springs are connected in parallel. So this is connected in parallel. They are connected in series. You can also use the formula. You will get the same result. And in this case, these two are in series. These two are in series. Then they are connected in parallel to each other. So these two are in parallel. This one is in series, and they are connected in series with each other. So you can also use this formula. Later you can try by yourself and you will get the same answers. If your answer is different, you can leave questions in comment section and I will answer. For question number 20, it is given to us an unstretched spring has a length of 2.0 centimeters. The spring is then stretched within its limit of proportionality by a tensile force of 1.5 newtons. This is the maximum force. The elastic tension energy stored in the spring is 0.045, means 0.045 joules. What is the stretch length of the spring? So the best way to answer this problem is we can sketch. First of all, when the spring is unstretched, so this is unstretched. Let's say this length is equal to L naught and the value of L naught is given to us. We can say this is L naught and value of L naught is given 2.0 centimeters. Then we apply force on this spring and this spring is stretched. So we can draw here. And question is asking us to calculate this length. Let's say this one is equal to L1. But we can calculate extension in the spring, means delta L we can calculate. Delta L we can calculate. So how we can calculate delta L? Because elastic potential energy is given to us. So we can say EPE, this is given to us, and this one will be equal to average force time delta L, average force. So we have F max, that is equal to 1.5, and initially force will be 0 divided by 2 times delta L. So here we have delta L. So simply we are using this formula. Don't get confused with this. EPE simply is equal to 1/2 F, but this F is maximum. Why we use 2? Because we need to find the average force acting on the spring. So I have written this one so you can have better understanding, not just memorize formula. So this is 1/2 F max time max, F max. So EPE in this case is given, so that is 0.045. So from here we can find out delta L. Delta L will be equal to 2 times 0.045, and this one will be divided by 1.5. So if we solve this one, our final answer will be equal to 0.06 meters. Or simply we can say delta L in this case will be equal to 6 centimeters. But we need to calculate L1, and L1 is equal to L naught plus delta L. So we need to calculate value of L1. Stretch length means the total length of the spring. L naught we have 2.0 centimeters. This is 2.0 centimeters, and delta L is 6.0 centimeters. So this is in centimeters. So our final answer in this case will be equal to 0.8 centimeters, and this is the total length of the spring after we apply force on this. Stretch length means the total length. So this is total length. So this is how you can answer, and we are done for today. We have done from question 11 to question 20, and in tomorrow's video we will solve next 10 questions. See you in next video. Bye for now.